In this session we do this page number 12. This is the second to do this problem in this page number 12. In this problem it is given that write the following rational numbers in the decimal form and find out the blocks of repeating digits in the question. Here 4 bits are given. We solve one by one. Here first bit is given, rational number is 1 by 3. To find the repeating digits, so we divide the numerator 1 with the denominator 3. So here we cannot divide 1 with 3 because 1 is less than 3. So we in the quotient we keep the decimal point and we keep the 0 after 1. It becomes 10. So now we divide the 10 with 3. So 3 3s are 9. By subtracting we get 1. We get 1 as a remainder. So 1 is less than the divisor 3. So we keep 0 after 1 because we already kept a point in a quotient. So now again 3 3s are 9. We get a remainder 1. Here 1 is also again less than the divisor 3. So we keep the 0 after 1. It will become 10. Again remainder 1. Get 3 3s are 9. By subtracting. This process is repeating because every time we get the remainder 1. So 1 by 3 can be written as 0.333. In quotient 3 is repeating. If we observe the denominator of the given rational number, the denominator not have 2 power n or 5 power n as a prime factor. So if denominator have other than 2 and 5 as a prime factor, then that rational number is a non-terminating repeating decimal. Now we solve the second bit 2 by 7. Here we divide the numerator 2 with the denominator 7 by long division method. 2 is the numerator and we divide 2 with the denominator 7. Here 2 is less than 7, so we keep the decimal point in a quotient. So we can write 0 after 2. So it will become 20. 7 2s are 14. By subtracting we get 6 as remainder. 6 is less than the divisor 7. So we keep the 0 after 6 because we already kept the decimal point in quotient. So 7 8s are 56. By subtracting we get 4 as remainder. 4 is less than the divisor 7. So we keep the 0 after 4. It will become 40. So 7 5s are 35. By subtracting we get the 5 as the remainder. So 5 is less than the divisor 7. So we keep the 0 after 5. So it will become 50. Now we get 7 7s are 49. By subtracting we get 1 as remainder. 1 is less than the divisor 7. So we keep the 0 after 1. It will become 10. Now 7 1s are 7. By subtracting we get 3 as remainder. 3 is less than the divisor 7. So we keep the 0 after 3. It become 30. Now 7 4s are 28. By subtracting we get the 2 as remainder. Here remainder r is same as the numerator of 2 by 7. So we get same quotient, get same digits in quotient. So digits 2, 8, 5, 7, 1, 4 are repeating block of digits in quotient. By observing the given rational number, the denominator is other than 2 or 5. It is 7. So in denominator we have 7. So the rational number 2 by 7 is a non-terminating repeating decimal number. In this rational number also denominator is not in the form of 2 power n or 5 power m. So denominator not have 2 or 5 as a prime factor. So it is other than 2 and 5. So in quotient we get the non-terminating repeating decimals. Now we solve the third bit 5 by 11. To solve this one we have to divide the numerator 5 with the denominator 11. Here numerator 5 is less than the 11. So we keep the decimal point in quotient. So we can keep 0 after 5, so it will become 50. So now we divide 50 with 11. So 11 4s are 44. By subtracting we get a remainder 6. 6 is less than the divisor 11. So we keep the 0 after 6 because we already kept a decimal point in a quotient. So 11 5s are 55. By subtracting we get the remainder 5. So 5 is less than the divisor 11. So we keep the 0 after 5. So it will become 50. Now we divide 50. 11 4s are 44. By subtracting we get the remainder 6. 6 is less than the divisor 11. So we keep the 0 after 6. It will become 60. Now we divide the 60. So 11 5s are 55. By subtracting we get the remainder 5. This is a repeating. So here repeating decimal is 4 5. In question 4 5 is a repeating block. We can write 5 by 11 is equal to 0.454545 and so on. If we observe the given rational number, the denominator is 11. It is not in the form of 2 power n or 5 power m. If denominator have other than 2 or 5, then we get a non-terminating repeating decimal. To find the repeating block of rational number 10 by 13, we divide the numerator 10 with the denominator 13. So here numerator 10 is less than denominator 13. So to divide this one, we keep decimal point in a quotient and we place 0 after 10. So now we divide 100 with 13. 13 sevens are 91. By subtracting we get 9 as remainder. 9 is less than 13, so we keep 0 after 9, so it will become 90. Now we divide 90 with 13. 13 6 are 78. By subtracting we get 12. 12 is less than 13, so we place 0 after 12, so it will become 20. Now we divide 120 with 13. So 13 9s are 117. By subtracting we get 3. 3 is less than divisor 13, so we keep 0 after 3, so it will become 13. Now we divide 30 with 13. 13 2s are 26. By subtracting we get 4. 4 is less than divisor 13, so we keep 0 after 4, so it will become 40. Now we divide 40 with 13, so 13 3s are 39. By subtracting we get 1. So 1 is less than 13, so we keep 0 after 1, it will become 10. 10 is less than 13. To divide further, we keep 0 in a quotient. Now we place 0 after 10, it will become 100. From here, if we further divide, we get the same process and we get the same quotient of again repeatedly. So 10 by 13 can be written as 0.769230. Because this block is repeating means we can write 7699230. This process will continue. So here repeated block in quotient is 7699230. By observing the given rational number, the denominator is other than 2 or 5. So if in denominator we have other than 2 or 5, then that rational number can be written as non-terminating repeating decimal form. From this problem, we can conclude that denominators have other than 2 or 5 as prime factors. So we can write these rational numbers as non-terminating repeating decimals. So here denominator is other than 2 or 5. In all these we have other numbers as a denominator. So any rational number in its denominator have other than 2 or 5, then that rational number can be written as non-terminating repeating decimal.